Alright, so I finally decided to start logging my adventures in designing a rocket that can land itself. I've been kind of developing this over the past couple of months, and I've yet to actually monitor my progress, so I figured I'd start doing that if I really want to figure out how fast I could build this, and hopefully getting it done by the end of the semester, not having the whole project done, but just having all the hardware and an actual working model that could reliably not fall apart in mid-flight. Hopefully I'll be able to continue the software next semester, especially since we're going to be doing like coding classes and stuff. So here are some designs that I had for this rocket. Here's what I was planning on having the nose cone open up, and then the thrust vectoring mount would like pop out from the nose cone, and then it starts actuating. Because I've seen like SpaceX or like this one guy Joe Barnard. He kind of inspired this project, and both of those people's companies they have like landing gears on the outside of their rockets that kind of flip out as it's about to land. However, I thought it'd be an interesting idea instead of landing gears flipping out, we have the nose cone open up. So therefore, like, it reduces the amount of drag on, like, say, ascent. If I wanted to turn this into like a rocket that goes up, and then as it's coming back down, comes up, nose cone up, and then it comes back down, nose cone opens up, and therefore you don't have to put landing gears on the outside. It reduces drag. You can actually get a higher. You should be able to get a higher altitude apogee by not having like all these landing gears and stuff sticking on the outside. But I might ditch the whole opening nose cone idea because, well, one, it sounds pretty dangerous in itself. Like having a nose cone that like you have all these creases on the inside that might actually hurt the aerodynamic drag more than like actually putting landing gears on the outside. Like if you had 3 creases to where the nose cone would actually fold out, say you have like a really big crease because the servo that closes and opens it didn't close all the way, or like changes during flight, that thing could get ripped open and all sorts of things could go wrong. You don't have that kind of, you have a little bit more, you're a little bit more safe when you put landing gears on the outside of your rocket, because you don't necessarily have to worry about the landing gears like snapping open as violently as like the nose cone, since the nose cone absorbs more of there's a lot more airflow hitting the nose cone rather than the landing gears. So I might switch to landing gears just for the sake of complexity, because this is going to be a real complex project, but hopefully I'll be able to achieve something within the next couple months. Alright, on to my 3D model of my thrust vectoring mount. So, let's see. This is what it looks like from the side view, the right view. It'll actually be able to pivot, not in the right view, but actually in the back view, sorry, by the servo motor. Like the servo motor like kind of pulls it this way using a linkage stopper, kind of like what they use on RC planes, and it'll just kind of pull it back and forth, and also controls it in the Y direction. So this whole thing, including the servo motors, will be actuated by another servo motor, and this whole thing will kind of like rotate against this axis. So altogether, when you move one motor and you move the other motor in conjunction, you could have this like awesome combination of like different motors moving, and you can do like circular motions, and you basically get almost all degrees of freedom except for yaw, because like you can't really account for the rocket rotating around this axis with just these 2 axes, the say X and Y axis. So yeah, that's my 3D working model in CAD. Probably get this printed out. My expectation is by October 17th, but who knows? Hopefully I'll get that done by then. Then I'll be able to keep this whole vlog kind of thing updated. So essentially what I have for this rocket, right? I'm going to use this pen as kind of a demonstration. This is like the nose cone of the rocket, and then say this like eraser is the thrust vectoring unit of the rocket. What it's going to do is, this first part I'm not too sure about, but somehow I'll get the rocket into the air, maybe by a drone or like possibly another rocket, who knows. The main part is landing it. So once it's in the air, falls down, somehow either the nose cone will open up, thrust vectoring mount will shoot hot gases depending on how it's falling. Say it's falling this way, it'll shoot gases this way so it can actually like rotate itself. It won't be this dramatic. It'll be more like plus or minus 5 degrees to actually stabilize itself. So either nose cone opens up, fires hot gases, stabilizes itself, lands itself. It'll be awesome. Ooh, right there, yeah. Or the nose cone doesn't open up because that's kind of really complicated, and it just ends up falling up, or it just falls straight down. There actually will be no nose cone, and it just falls straight down. Thrust vectoring tube just lands itself right instead of the nose cone opening up. And like landing gears, say this, like kind of pop out or something, and land it, like help it like stabilize itself as it's on the ground, so it actually has something to like not pivot on, you know. So essentially what I have for this rocket, right, I'm going to use this pen as kind of a demonstration. This is like the nose cone of the rocket, and then say this like eraser is the thrust vectoring unit of the rocket. What it's going to do is, this first part I'm not too sure about, but somehow I'll get the rocket into the air, maybe by a drone or like possibly another rocket, who knows. The main part is landing it. So once it's in the air, falls down, somehow either the nose cone will open up, thrust vectoring mount will shoot hot gases depending on how it's falling. Say it's falling this way, it'll shoot gases this way so it can actually like rotate itself. It won't be this dramatic. It'll be more like plus or minus 5 degrees to actually stabilize itself. So either nose cone opens up, fires hot gases, stabilizes itself, lands itself. It'll be awesome. Ooh, right there, yeah. Or the nose cone doesn't open up because that's kind of really complicated, and it just ends up falling up, or it just falls straight down. There actually will be no nose cone, and it just falls straight down. Thrust vectoring tube just lands itself right instead of the nose cone opening up. And like landing gears, say this, like kind of pop out or something, and land it, like help it like stabilize itself as it's on the ground, so it actually has something to like not pivot on. Alright, and on to more of the hardware, like electrically speaking. So this is just a pile of junk right now. Nothing's really like working, nothing's really like, you know, plugged in correctly. I don't have everything wired like to where everything looks pretty neat. It's all just kind of slapped in together to make sure everything, you know, would plug in at least the right spots, and I would have enough ports kind of open, especially for the IC squared bus and the SPI bus. Like, there's so many things that connect to that. Like, for example, this micro SD card, this OLED display. What else connects? I think this this receiver, or actually it's going to be a transmitter on the rocket. This uses SPI as well. And I think that's about it, but having all those connections and using the Arduino Mega, it's actually pretty helpful, because the Arduino Mega has like 52 outputs, I think. Something, yeah, 53? About 53 digital outputs, so like they're all pretty much capable of supplying all the demands I need for SPI and I2C protocols. So basically what I'm planning on doing is having like these 4 servo motors. These will either control the nose cone opening, and or you'll have some servo motors actually controlling the gimbal. So like 2 of them will be dedicated to the gimbal thrust vectoring unit. 1 of them will be dedicated to hopefully either opening the nose cone as it falls, or it'll be used for opening the landing gears as it falls, depending on which route I take. And then I went ahead and just plugged in an extra servo motor, because I might use that for, you know, who knows, maybe a backup parachute deployment, or there are a multitude of things that you can use this for. I'd rather plug in 20 servo motors and, you know, not have to plug in extra ones and, you know, try to figure out different spots that I have to hook them up in, then end up having not enough servo motors. So that covers that. For this SD card logger, it'd be helpful to actually gather data while I'm testing this, because every flight's going to be used as a test. It's not like a one and done kind of deal. I launch and then woohoo. So I'm just going to be using this, just a basic micro SD card adapter to be logging data from the rocket. It'll just be collecting data from temperature sensors, barometric pressure sensors, magnometers, accelerometers, gyroscopes. All sorts of data is just going to be logged onto this after flight. Hopefully I can figure out how to get it from EEPROM to the SD card instead of having it constantly update to the SD card, because that's going to slow down the processor like way down. I tried using this in my last project where fins would actuate as it flies up, and it just wasn't worth the clock cycle. Like it took the clock cycle about like 10 times as long, adding in every single every single loop. It would refresh data to the micro SD card, and it just wasn't worth the wasted time spent. So I just didn't log data on my last rocket, which is it's pretty bad because I still wanted to experiment with it, but it was really hard to. So I might try to figure out how to store it on EEPROM, then log it to the SD card afterwards and see how that works. For my next module, I have a GPS. This will kind of help with figuring out how high you are. It'll give me like a kind of like a low pass filter, I think, where it kind of slowly updates your information. You can like check what your other sensors are giving you with this, like, yeah. And then I also have a little speaker somewhere in here, this tiny thing, as like you could have it as protocol, like as it beeps like 3 times, you know you're ready. When it holds its like beeping, you know like it's armed or something. Plus, finding these freaking rockets is such a pain in the butt when you're in like a kind of like grassy area and you paint your rocket green or something. I don't know. It would just be easier to find the rocket if you had some annoying buzzer like this I bought from Radio Shack. Rest in peace. Rest in peace, Radio Shack. But, and then, I also have this OLED display I'm going to be putting on my rocket. So this will kind of hopefully sit on the side. There's not really much use to this except for just convenience, like being able to see all your data, like the status of the rocket and stuff like that. Like having this mounted on the side, that'd be like really cool. Like you could just see, it's like having mission control on your rocket. So like you could check like all your readings, see what needs to be rebooted, or like see what's like if everything's connected properly, instead of having to like have your bring your whole computer onto the rocket launch and then like start checking stuff there. You already have a computer here, so I figured I'd go ahead and put a display, and you know, I just spice things up, you know. And then I have this transmitter. So this transmitter, one, might be useful for deploying a parachute just in case the thrust vectoring unit doesn't like start working, or like landing gears don't pop out. You know, if anything were to go wrong, I could always send a signal to this rocket, and like this receiver would try to like overload, or you know, stop whatever it's doing, stop whatever processes this is doing, the processor, and would deploy a parachute. So like instead of like continuing to try like to fire the thrust vectoring unit, even though like maybe a wire is disconnected, you don't know, it would override that, and it would just deploy the parachute, so you don't end up having to lose like a lot of time and a lot of effort in building this rocket. So yeah, that's I think that covers just about everything except for blue LED. You can't go wrong with a blue LED. Blue is my favorite color. And then of course all of these hopefully if I can figure out this whole solenoid valve situation, if I want to invest in like better solenoids to get to actually get more airflow coming out of these, hopefully I'll get to use these on this, and like this will control this. Oh yes, last but not least, on the inside of this, kind of buried underneath it, but you can kind of tell, these wires are connected to a 10 degree of freedom Adafruit like kind of deal gyroscope, accelerometer, pressure sensor, temperature, magnometer, which I thought was pretty interesting. All that I kind of like soldered on underneath this breadboard on the inside. So I kind of put it in, like I mounted it in the center of this, so this whole thing could kind of sit in the center of mass of the rocket, you know, where the electronics bay would go. And that would just measure like figuring out how fast it's going, where it is, where it needs to be, you know, all those kind of readings. It would be helpful if it had an IMU, like it already like did a Kalman filter like on it, but however this version I do not believe comes with that, so I'm just gonna end up hopefully coding it myself and kind of learning along the way on how to do that kind of stuff, knowing how fast you're going. I think that's using like quaternions or something, some higher level math that I'm doing right now in Calc 1 for Engineering 101. Alright, so I think that's just about everything for this project, for the hardware at least. Hopefully everything, because I don't want to buy more stuff. I don't want to spend money. I'm a college student. So yeah, that's basically my project. Hopefully I'll be coming back to this vlog in a week. If I don't come back to a vlog in about a week, I'm gonna be very mad at myself, because that means I'm slacking. You know what they do to slackers? They put them on space shuttles and send them away. I'm just kidding. All right.